Hey everyone, it's Mr. PK here. Today we're going to learn about density. Density is a property of matter that measures mass per unit of volume. In other words, density is equal to mass divided by volume. Mass is how much stuff you have. It's how much matter is there, how many atoms or molecules, whereas volume is how much space the object takes up. So the more matter that you can squish into a given volume, means you'll have a denser object. So the more mass in a given space, the denser the object is. The density of water is 1 gram per milliliter. If an object floats in water, it has a density less than water, so it would be less than the density of water, which is 1 gram per milliliter. If an object sinks in water, it has a density greater than 1, so its density is greater than 1 milliliter. 1 gram per milliliter. If an object is suspended in the water, like it's not going to the top, not going to the bottom, it has the same density as water. So it's equal to water's 1 gram per milliliter. So describe the density of the object here. This object is floating, so its density is less than water, less than 1. This one is sinking on the right, so its density is greater than 1. And this one is the same as water. One really cool thing about the density of an object is that it always remains the same. So just like if you have a drop of water or a puddle or a lake of water, that water has unique properties that will be the same in all three cases, its density is one of those things that remains the same. The same amount of matter in a given space, 1 gram per milliliter, is the same throughout all these examples. So 1 drop of water has the same density as 1 puddle of water and 1 lake of water. That is, of course, if there's nothing dissolved in this lake and it's pure H2O. So how do you find the density of an object? Well, density is equal to mass divided by volume. So you need to find mass, and then you need to find volume. To find the mass of an object, you're going to use a triple beam balance, right? There's 3 beams. You find out the mass on them all and add them up. To find the volume, it depends on whether it's a regular object or an irregular object. If it's a regular object, you have, say, like a cube. You measure the 3 sides and multiply them, length times width times height. If it's an irregular object, you're going to do water displacement. So let's say you have a certain amount of water. Let's say you have 5 milliliters. You drop an object in, and then it jumps up to 10 milliliters of water. All right? What happened? It went up by 5. So what's the volume here? Your volume is 5 milliliters. You do 10 minus 5. All right? And this just goes into more detail here. How you find the volume of a regular object, how you find the volume of an irregular object. And the volume of a liquid, if you were to do the volume of a liquid, it would be just looking at the bottom of a meniscus. Okay, so density is grams per milliliter or grams per centimeters cubed. Again, like we said with the drop of water, a puddle, or a lake, the density of an object never changes. So let's say you have this block right here, and its density is 2. If you cut it in half, its density will still be 2. Think of it this way. Let's do the math. So density equals mass divided by volume. It equals 8 grams divided by 4 centimeters cubed. 8, 4, which equals 2 grams per centimeters cubed. You keep the units. All right, same over here. Density equals mass divided by volume, which is 4 grams per 2 centimeters cubed. What's 4 divided by 2? 2 grams per centimeters cubed. So they both equal the same thing. If you cut it in half, the object still has the same density. So this brings us to our density triangle. You won't always be solving D equals M over V. You might be solving for one of the other variables. So how this works is you put D in the bottom left, M up top, V to the bottom right. And whichever variable you're solving for, you put your finger over it and look at what's left. So notice that M is over V here. What do you do when a number is over another number? You divide, right? So between the m and v, you divide. So if you're looking for density, it's equal to m over v. Let's say we're looking for volume. If you don't know volume, you have m over d. And what do you do when m is over d? You divide. So v equals m over d, which is right here. And what if you don't know mass? You cover up mass, and what's left? These two letters next to each other. What do you do when two things are next to each other and you don't see an operation between them? Well, you know to multiply them, all right? So if you're looking for mass, it's equal to d times v, which is right here. So those are the three parts of the density triangle. And now let's do an example of each one, okay? So you have a rock with a volume of 15 and a mass of 45. What is its density? So here you want to figure out which of the three you're solving for. So you're looking for density, right? It says it in the question. So you're going to list all your variables. Your density is equal to, well, we don't know. Your mass is equal to 45 grams. It says it right there. And your volume is 15 centimeters cubed. So when you solve for it, you cover up d, and what do you have to do? You have to do m over v. So it's d equals m divided by v. So d equals m over v, and then you just plug these in. Density equals 45 over 15. So what's 45 divided by 15? Your density is 3 grams per centimeters cubed. All right? So that's the density of your rock. If the density of a diamond is 3 grams per centimeters cubed, what would the mass of the diamond whose volume is 1.5 centimeters cubed? So what would the mass be given the density and volume? So what are you solving for? Well, even if you can't tell from the question, let's write out what we have and don't have. So the density is 3 grams per centimeters cubed. Your mass doesn't say. Your volume is 1.5 centimeters cubed. So what are you solving for? Your mass. So if you're looking for mass, you cover it up on your density triangle. And what's left? D times V. So then you do mass equals D times V, which is equal to 3 grams per centimeters cubed times your volume of 1.5 centimeters cubed. I'm going to write it like this, so you'll see in a second. You could just write 3 times 1.5. But look at this. You have centimeters cubed on top, and you have centimeters cubed on bottom. What do you do when you have the same thing on top and bottom? You can cross them out. All right, so now you have 3 grams times 1.5. What's 3 times 1.5? It is 4.5. 4.5 what? Grams. So by crossing it out, I knew to use grams. But let's say you didn't cross it out and didn't know. Well, think about mass. When you measure the mass of something on a triple beam balance, you're looking at grams. All right, and 3, if a 100-gram piece of aluminum has a density of 2.5 grams per centimeters cubed, what is its volume? So what are you solving for? Well, this one's pretty easy to see. It says volume. But let's just write out our variables again. So you have a 100-gram piece of aluminum. What does grams represent? Mass. So you have a mass of 100 grams. You have a density of 2.5 grams per centimeters cubed. That's your density. So what are you solving for? Volume. That's what you don't know. Okay, so going back to your triangle, your density triangle, if you cover up volume, what do you have left? M over D. What do you do when one's over the other? You divide. So you get V equals M over D. So let's write that in here. V equals M over D. And then we're just going to solve for volume. So volume is equal to 100 grams divided by 2.5 grams per centimeters cubed. Okay, so what's 100 divided by 2.5? All right, it is 40. So what are your units here? Your units for, wait. Yeah, I did that right. Just checking. Okay, so your volume is 40, and what are your units for volume? Centimeters cubed. It's either going to be milliliters or centimeters cubed. Since this question used centimeters cubed, we're going to use that. And if you look at your units and you kind of flip them around, you could also cross them out and get centimeters cubed. But it's a little complicated because there's a lot of divide signs. So you can just think about what you're using, and it's centimeters cubed. So from this sheet, we did an example where we're solving for density, for mass, and for volume. And notice it's all using the same triangle. You just cover up whatever you're looking for. And then you, whoopsies, and then you write out your variables. You write your formula, and then you substitute them in, do your math, and then don't forget your units, all right? And so that's all you need to know about density right now. And thank you for watching this video.